Okay, talking about inverse functions today, 6.2. Let's just talk about what the concept of an inverse is. An inverse relation, right, whether it's a function or not, is obtained by exchanging the x and y values. So just remember that. You're walking down the street, you hear the word inverse, what pops into your head? Exchange x and y values, right? Now, when we have our function, right, and if you want to look for the domain of the function, you scan horizontally for all the x's, right? So the domain is always associated with the x's. And if you want to find the range of a function, you scan vertically and you look for all the y values where there is a graph. So the range is associated with the y values. All right. Now, in finding an inverse, when we switch x and y, then what else is being switched? The domain and the range, okay? And we will revisit this in a few minutes. Okay, here you've got a relation, and I know that I'm missing some brackets and parentheses here. Now they're back. And you're asked to find the inverse of the relation. All right, well, if the inverse is found by interchanging x and y, then for each coordinate point, we're going to interchange x and y. So if for the first coordinate, this is x and this is y, if I switch them, instead of 1, 3, I will get what? 3, 1. And what about for the next one? 3, 6. And what about for the next one? 6, 0. And 0, 1. All right, so all I do for each coordinate point is just swap them. Okay? Now, I'm going to graph both the original and its inverse. So I'm going to graph the original in black ink. I have a point at 1, 3, 1, 3. I have another one at 6, 3, one at 0 and 6, one at 1 and 0. Does that sound right? Does that look right? Say yes. Yes. Good. Now, in purple, oh, 0, 6. I got those wrong. Ooh. And x is 1, y is 0. That's off too. So x is 0, y is 6. X is 1, y is 0. Is that right now? Okay, and I have a 1 and a 3, and I have a 6 and a 3. Okay. And I never said that this was a function. I just said that it's a relation. So I could have 2 points on the same vertical line, right? All right. Now in purple, I'm going to graph the inverse. So when x is 3, y is 1. When x is 3, y is 6. 2, 3, 4, 5, 6. When x is 6, y is 0. When x is 0, y is 1. All right? What does that look like? What do you notice? For every black dot, there is a what? Look at this. For every black dot, there is a corresponding purple dot. Every black dot, a corresponding purple dot. For every black dot, a corresponding purple dot. For every point on the relation, there is a corresponding point on the inverse, right? Do you see how cool that turned out to be? Right? Come on, that's so cool. Does it look like the black dots are being mirrored into the purple dots? And where is the mirror, quote unquote? What line is the mirror? It's that red line, right? So, what does it all mean? Look at all the original ones. Okay? If you draw the relation and then if you draw this line through the middle, diagonally through the middle of the axes, and if you mirror each of them around it, you get its inverse. Okay? And what is this line? What's the y-intercept of this line? The red line. What's the y-intercept? 0. And what's the slope? 1 over 1. So this is the line y equals x. All right? So a function, right, when I draw the line y equals x, f of x equals x, that's the reflection of the function and its inverse, always. All right, so let's look at the original function again, the original relation. And what we want to do now is we want to determine what the domain is. So remember when you had discrete points, the domain is just the collection of all of the different x values. So what are the x values that appear here? I have a 1, I have a 6, a 0, and another 1, right? I don't write the repeats, so it's just a 0, a 1, and a 6. So my domain is 0, 1, 6. Now, what about the range then? What do I have? A 3, a 6, and a 0. So 0, 3, 6. Okay? Now, let's do the same for the purple one, for the inverse. What is the domain? I have a 3, a 6, and a 0, so 0, 3, 6. And for the range, it's 0, 1, 6. So what do you notice? That it's switched. So the domain of the original became the range of the inverse, right? And the range of the original became the domain of the inverse. All right, so they always switch. Okay, so that much about exploring what inverses are to begin with. Now, and we figured out how if you have a graph, you can get the, right, if you have points, how you can graph the inverse. Well, what if all you're given is a function f of x, and you want to find the inverse? What do you do there? First of all, a little bit of notation. If f of x is the name of the function, then the name of the inverse is this, f to the power of minus 1, but it's not to the power of, it's just a label for inverse of f, okay? All right, so here's what we do. First and foremost, you change f of x and you just label it as y, because I don't want x and f of x, I want x and y. Then exchange x and y, solve for y, which we all love, and then you have to replace y with a new label. Okay, what does it all mean? Let's do one. Yeah, there'll only be one. And then you solve for y. So let's do one, and you'll see. Okay, so first I have f of x equal to 2x minus 2. Okay, what does the first step say? Change f of x to y. Okay, I don't want to write it as f of x equals. I want this to be y equals 2x minus 2. Okay? Now, what's the next step? Number 2. Exchange x and y. So this becomes x, that becomes y. Everything else stays the same. Okay? Next step says to solve for y. Can we solve this one for y? I add 2, I add 2. So what do I have? X plus 2 is equal to 2y. Right? Now what do I do? Divide by 2, divide by 2, divide by 2. So here I have y, and here I have 1 over 2x plus 1. Right? So y equals half x plus 1. What's the next step? Replace y with what? F inverse of x, right? I can't call this y anymore. I cannot call it y. This has to now be called f inverse of x. So I say f inverse of x is equal to half x plus 1. Okay? Should we do another one? Yeah. Yay! Okay, before we go on to the other one, let's graph these two. Let's first graph the first one, f of x, right? It's 2x minus 2. Remember how we graph these? What's the y-intercept? -2, and what's the slope? 2. So I go up 2 over 1, and let's see. Huh? Right, the y-intercept is -2, and the slope is 2. Okay, now I'm going to graph the purple one, f inverse. Y-intercept is 1, and what's the slope? Up 1 over 2. Look at that, guys. What do you notice? The purple and the black, right? They're just reflected over that red line. Okay? So look at this one. If I were to take the black and just like mirror it, flip it over around that red line, I get the purple one. Okay? And that's how you know that they're inverses. Questions? I graphed this one, half x plus 1. So y-intercept is 1, and I go up 1 over 2. Okay? All right, let's do that one. Who is this? Okay. All right, so first I'm going to call it y equals. Now I'm going to exchange x and y. Okay? Now what am I going to do? Subtract 3. Now what am I going to do? Take a square root of both sides. So y equals what of the square root of x minus 3? It's what? Is it just root x minus 3, or is there something in front of it when you take a square root of both sides? Plus or minus the square root of x minus 3. Now, can I write this as f of x equals, f inverse of x equals? Well, not only can I do that, I have to do that. So that's my inverse. So the math really ends here, and then that last step is just to relabel. Okay? So what does that mean? That means I have two functions. One of them is f inverse of x is root x plus minus 3. And the other one, f inverse of x, is negative root x minus 3. Okay. Now, let's graph that black one. What is that graph going to look like of the x squared plus 3? Right, but what it'll look like a parabola, right? And it's a parabola that's moved up 3 units. So it starts from here, 1, 2, 3, the vertex is there. Now, let's pick points. When x is 1, I put 1 in there. 1 squared is 1, plus 3 is how many? 4. So when x is 1, y is 4. And since it's a parabola, does it have a corresponding point on the other side? It does. And I'm not looking for NASA precision right now, so let's just graph it like this. Okay? Huh? Which one? This one or this one? Or this one? The first, the second, or the third? For all of them. Okay, so this is x squared, which means it's going to be a parabola. But since it's x squared plus 3, the plus 3 shifted up 3 units. So the vertex I know is at 1, 2, 3. No, I know that. Okay, here I just picked x equals 1. I'm plotting points. I'm making a table of values. No, I know that, but the second part you bought. Oh, here? Oh. Okay, so this was, I took a square root, right? And I got y equals the square root of x minus 3. Oh, I haven't graphed that one yet.
Oh, that was
Now I'm going to graph that. Okay, see? Black. Now purple, I'm going to graph the purple. Okay. So, there are two versions, there are two of them here. I'm going to graph this one. This is a square root graph. Do you guys remember what square root graphs look like? Okay, you know what we're going to do? We're going to pick points. Okay? When x is 0, what is, can we have 0 in here? When x is 0, we get the square root of -3, so that doesn't work, right? What about when x is 3? What do I get? 3 minus, okay, so when x is 3, y is 0. What about when x is 4? I'm just plugging in numbers. So I'm doing x and then the square root of x minus 3, right? So when x is 3, I get 3 minus 3 equals 0. When x is 1, when x is 4, I get 4 minus 3 in the root. So what is that? Root 1, which is 1. Okay? And what else should we put in there? Let's put 7. Yeah. 7 minus 3, that's what? Root 4, how much is that? 2. So when x is 7, this is 2. So look, it looks like this. Okay? Now I'm going to graph this one. What's the difference between this and this? There is a negative, so what does it do? It flips it down. Do you guys remember from chapter 2? It flips it downward. So everything here is going to, all the points will move to their corresponding points down here. So it'll look like that. Okay, so now compare the black and the purple. Do you see how they're flip-flopped around the green red? Okay? Now, if you are not absolutely comfortable with graphing all of these by hand, is that okay? Yes, it is. Can you plug them in your calculator and do it? Yes. Are you really going to have to be graphing all of these manually? Not really. The main reason why I'm doing it is just to show you that the function and the inverse really get flip-flopped. What I want you to know how to do is this part, okay? And what we're going to do next, okay? Yes. Reflections, but around that line. This one was wider than you think? Well, the thing, if you mirror all of them like this, around, and they're the same. That's what I mean? It has to be reflected like that. So it's turned over on its side. See how it's turned over? Yeah. Yeah. But the graphs too, it's basically it's like you took this and you flipped it and it's over there. Right? Because it's a line, it's easier for you to see visually. Yeah. Yes. The negative, what I did is, it's the negative of this, right? So I took that and I flipped it over. Yeah. Okay. All right. So next we're talking about verifying inverses. Now you have two functions. You're walking down the street. There is a billboard. Function 1, function 2, and you go, man, I wonder if those are inverses of each other. Well, guess what? You can totally check. Okay? So let's check. Here's what we're going to do. we're going to find f of g of x, and then we're going to find g of f of x. And if we get x for the result for both, then they're inverses. Let's do one and you will see. So what I do when I have these problems is I split my work area down the middle. So now, I want to find f of g of x. Okay? So remember how we did that on the homework? What's the outer function? The outer function is f of x, which is 3x minus 3. So now, what would f of g of x be? Right, so it's 3 times 1/3 x plus 4 minus 3. Right? This is what you were doing on last night's homework. So this is f of x, now f of g of x. So I'm going to substitute g of x into the x. All right? Now, let's distribute. This is going to be, what's 3 times 1/3? 1x plus 12 minus 3. How much is that? X plus 9, right? Is that the same as just x? Is x plus 9 the same as just x? No. That means this already failed the test. So I just say, nope, not inverses. Okay. Now, let's do the other one. Split your work area down the middle. And first I want to find f of g of x. What's the outside function? F of x. And that's 2x squared minus 1. No, it's an all or nothing deal. Okay? Yeah. Yeah, so look at how this is going to turn out. So now I want f of g of x equals 2 times. What am I going to put in for x now? Right? And all that gets squared. So it's important that you have, good bookkeeping skills so you don't lose sight of things. Okay, now, what does the square do to the square root? Makes it go away. So I have 2 times x plus 1 over 2 minus 1. Can I cancel the 2's? Yep. Well, I just did, so I guess you could. So now what do I have? X plus 1 minus 1. What's that equal to? X. Oh my God, guys, there's hope. There is hope. Okay, now we got to do the next one, the other one. For the other one, I'm going to do g of f of x. Okay, so what's the outer function? It's g, so it's x plus 1 over 2 in the square root. So g of f of x is the square root of. Okay, I'm going to put in this thing, 2x squared minus 1. And everything else just stays the same. Now, what does the top give me? This goes away. 2x squared over 2. What can I do with the 2's? Cancel them. I end with the square root of what? X squared. And what's the square root of x squared, guys? X. And look at that. Look at that. I did f of g of x and I got x. I did g of f of x and I got x. What does that mean about those two functions? They're inverses. All right, now, what if I didn't get x and x? What if I got 1 and 1? Would that work? No. What if I got 0, 0? No. 2x, 2x. No. It's all or nothing. It either has to be both x and x or not or nothing, right? Okay, so that's how you know that they're inverses. Now, this homework will be due Monday. Oh no, yes, Monday. That's all.